thought it'd be nice to have a video for this next section because it's not difficult really, but it's different looking, so it'd be nice to just kind of go through and make sure that you are comfortable with what you're looking at or looking for, I should say. So it's area of a regular hexagon. A regular hexagon means it's a six-sided figure where all sides and all interior angles are congruent, meaning the same measure. So it's almost like a square, but with six sides. And the area is pretty complicated to find the exact area. So what we typically do is we'll put it into an approximate form. And so 3 times the square root of 3 divided by 2 is about 2.598. And so that's much easier to plug into my calculator than all this stuff. So if they give me the side here on the regular hexagon, that's known as A, I just have to do 2.598 times that squared. And again, that's just really plugging that into your calculator. So 2.598 times 4 squared. Squared key, I don't know, or you could do 4 times 4. I don't know what kind of calculator you're using, but so I got 41.568. So we do 41.568, and this is inches squared. That's what that little double thing means. You're not always going to be given the side length, and that's what kind of the rest of this sort of talks about. That sometimes I'll be given the distance across from angle to angle, or sometimes I'll be given what they call the distance to the flats, where it's center of the flat side to center of the flat side. And I just need to be able to work with my diagonal and my flat to find A. And so the diagonal is twice A, so A is half of the diagonal. And the flat is 1.732 times A, or A is 0.577 times the flat. So if I'm given that value, that brings us into our next sort of information or problems on here, where if I know that the cross section of a hexagonal nut measures 3/4 of an inch across the flats, that means I know what F is. I can find A by doing 0.577 times F. What I typically do is I'll take, oops, I'm looking at the wrong one. I want to go, this is the one I wanted to do, sorry about that. This one gives me A and wants me to find the distance across. What I typically do for these is I'll just convert that into a decimal. So I would be using 0.5. For a piece of a hexagonal bar stock, A is a ½ inch. What is the distance across the corners and across the flats? So I'd also need the flats too. And I'll go back. F is about 1.732A. So my diagonal is 2 times 0.5. My flat is 1.732 times 0.5. And that's just really a matter of plugging that in the calculator. So for this one I get 1, and for this one I actually have to do the math. 1.732 times 0.5. To get that value I got 0.866. 0.866. So that's my F, that's my D. And I just have to pull those formulas out. You might want to keep that sheet handy with the formulas, whether you're finding A or D or F or whatever. So if side length, if I'm given the flat, how do I find A? That's that formula. Again, I'm going to take this and convert it. 3 divided by 4, that was from a previous lesson, converting into decimals, so I'll use 0.75. If it comes out nice, use the exact. If it doesn't come out nice, then you might need to round. So this would be 0.577 times 0.75, and again, it's just a matter of plugging it in your calculator. At 0.43275. The little squiggle equal means it's just approximately equal to, so that means they must have rounded this. Just so you know that it's not an exact answer, it's just an approximate. So what I just found here was A is roughly 0.43275. or 43275. If I want to find the distance, I need A, so my D is roughly equal to 2 times 0.43275. I already have that in the calculator, so I'm just going to multiply by 2. That gives me 0.8655. You're going to be dealing with a lot of decimals in this stuff, so just be aware, not a big deal. Like I said, a little rounding might be necessary. Now, if I want to find the area, then I'm going to go back to that area formula from the beginning, that 2.598 a squared. So I need A. A I found here. Oops. Here in that first one. So I do 2.598 times 0.43275 squared. Just a lot of formulas. I got 0.4865-ish. And my original was inches, so I say inches squared for area. Basically the same stuff on the next one, except for I'm given, in this one, I'm given A, excuse me for my sneeze. Again, I'm going to do 3 divided by 8 to get a decimal. 0.375 is what I'm going to use for that, 0.375. I have to find F. I do 1.732. Again, these are just formulas from that previous page in your notes, so you'll just have to look at your notes. So F is roughly 1.732 times 0.375. Again, plugging it in a calculator and getting an answer. .6495 inches. And then this is find the diagonal D. D is twice A. So I do the math on that. 0.75 is what I get for that. And then find the area. The area is 2.598 times A squared. And then it's in inches, so whatever I get, I'll put inches squared. And 0.365-ish is what I got. A little bit of rounding involved. Okay, so that's it for the regular hexagons. But the other thing you're going to get into is like areas of figures that have like different shapes. And so when you do that, and I don't need to go through all these, I don't think, what you kind of want to do is just maybe divide it into pieces. Like this is a rectangle that's 22 by 6, so it's 22 times 6 plus, then this guy is a rectangle that if this is 12 and the whole length is 22, that makes this, or sorry, if this is 10 and the whole length is 22, that means this other piece, because 10 plus 12 would be 22, so that's a 12 by 13 shape, so I do 12 times 13, and then again it's just plugging it into the calculator. Now it's not, you don't just have to add, so 22 times 6 plus 12 times 13 gives me 288. 288, and that's all inches, so inches squared because it's area. So there are two ways, they say, of finding this. I can do the addition part where I break it into pieces, but I could also do a subtraction where I figure out the area of the whole thing and then minus this piece that's cut out. So I could do this as 22 times this length would be 6 plus 13, so that's 19. So it'd be 22 times 19 plus, or sorry, minus, that would be the whole thing, minus 10 times 13, that would be the little piece. So 22 times 19 minus 10 times 13, and again I get 288. Again, it's the same value, it was just a different method, adding versus subtracting. And do whatever's works for you. Some of them are going to be easier than others. You know, like where this one, maybe I would do 2 triangles. Nah, I don't know if that'll work. Maybe I would do, you know, I might just have to look back at some of my formulas. Probably I would do this whole thing here, minus this little piece, maybe. Whatever, it's just going to be kind of playing around with, messing around with, trying to figure out what the best way is to get a value. I could even cut it in half and do this minus this little piece. That might be a nice way to do it. So I could do, I think that's the way I'll do it. I'll do this piece, which would be 13 cut in half. So 16.5 by 16. So area of that triangle is 1/2 of 16.5 times 16. That will give me 0.5 times 16.5 times 16, 132. And then I'll take out this little piece, which is 6 by 16.5, so that's half of 6 by 16.5 base times height. These flipped, it doesn't really matter, I can put them in any order. So I'll plug that in, 0.5 times, hi, 6, what's up, 16.5.
We'll do
49.
right now, or you got it?
I'm making a video.
Okay.
But I'm almost done, so you can come in if you want to. I'm just going to keep talking to myself while you're in here.
Okay, it's gonna have to run right across there.
Okay,
Whatever-
yeah, I'm almost done with
whatever it
this.
is,
Just give me,
so-
yeah, give me a moment and then
If it
I'll
don't work,
finish
we can
up.
do it tomorrow, too.
No, that's okay. I'll just finish this up and then you can do it right now.
Okay.
Right now, that's fine. Okay, so then I'm going to take these two numbers and subtract them. 132 minus 49.5. 132 minus 49.5. Get that value. That's 112.5. But that's only for half of this. I need to double it to get the other half. So I'm going to multiply that by 2 to get the rest of it. So my answer times 2, that gives me 225. I end up with 225. This little 1 dash is feet, so it's feet squared. So some of them you're just going to kind of have to play around with using your formulas. Some are going to be easier than others, just rectangles and things like that. But if you have a question, just let me know.